to start with negatives and positives. So let's make this a little bit bigger. See that back there? We good? Okay. When you look at this here, remember you're subtracting a negative, so that's the same as what? Adding. So you're going to rewrite this as 16 plus 23. And then now you're adding opposites. So 16 of the negatives are going to cancel out 16 of the positives. So you're going to have positives left. How many would you have? 7. Okay. Let's do this one. Absolute value. Oh yeah, Adam. It is the same thing. It's the same thing. Yeah. So that works. So here, absolute value -7 is what? 7. And so 7 over 51 is fraction. Check to see if it reduces. Does 7 go into 51? No? 6? Exactly. So, okay, it does go in 7 times, but since there's a remainder, it doesn't reduce. Okay? Let's say I changed the problem and I said, what about the absolute value of 17 over 51? If that were a different problem, we'd get positive 17 over 51, but then you would reduce that because both of these numbers are divisible by 17, so we'd say 1/3. So when it's reduced, when it's a fraction that you can reduce, write it in simplest form. If it's not, you're done. Does that answer your question? Okay.
So it's 7 and 1/3?
So, no, I made a new problem. Right? This was the first problem. Let's call this problem 3B. Second problem. I was just saying, if it's not something that you can reduce, leave it in fraction form. If you get something like this that you can reduce, leave it in simplified form. Noah.
Wait, but isn't it still in, I think it is, wait, can you just say 751s?
Yeah. You leave it as 751s.
Oh.
Olivia?
So you wouldn't try to divide 7 into 51 and like have a remainder?
Nope. You would just reduce your fractions. Okay? Good questions, you guys. Okay, on this problem here, remember you're going to do parentheses first, so I'm going to just copy here. And this is taking -15 and squaring it. So when you square a negative number, you get a positive. So that becomes, what's 15 squared? Natalie. 225, right? And it's positive. So we did the parentheses and that first set of exponents. Now, this right here, this negative, that's the opposite of 4 squared. So we have to calculate the exponent first. So that's 4 squared is 16. So we're going to do the opposite of 16 times 225. Does that make sense? And then what's 16 times 225? What did you get, Emma? -3,000. Pardon me? 600. Anybody else get that? Okay, just a second. Do we all agree that when you multiply 16 times 225, you get -3,600? What did you get, Adam? Okay, so let's check it. So you could do 10 times 225, right? And that would be 2,250. Use the distributive property. And then add 6 times 225. That might make it a little bit easier. So let's work out 6 times 225. You guys want to work that out? 6 times 200. So 225 times 6, we can work it out the long way. 30, 12, 13, 14, 15. That's 1350. And when we add those, we get, I get that. I agree with the answer. Do you guys see your mistakes? Okay. Good to check. Natalie, let's go to your question. Oh, Vanessa, was it your question? Somebody said something about an even. Oh. How did I get 225? I can't hear you. As a positive number? Because a negative, this right here is negative 15 times negative 15. And that's a negative times a negative, which gives you the positive.
So why would negative 4?
Okay, because this right here, that's the opposite of 4 squared. So you square 4 first and then put a negative in front of it because it's the opposite. See the difference? That's why I made that problem up, just so you would ask that question. Okay, so this one is an easy one. I just put this here in case you were not clear on what that meant with parentheses. It still means taking away a negative. So it's still the same as 7 plus 9, which is 16. So the point of that was to notice that when I write a problem like this, it's actually the same as number 1 above with the parentheses. Your book does both, so I want you to see both. Should I keep going? Okay, so let's go to problem 4. Noah, what did you do first?
I did 16 plus 14 is 30.
Okay, so 30, good. Then copy the rest of the problem down. The dot means multiply. Keep going, Noah. Correct. 15.
And 15 times.
Multiplying, you get 45. Okay, good. Let's see. Xander, what'd you do on number 6? What'd you get? Negative 5. Okay, so negative 5 to the third power is the same as negative 5 times negative 5 times negative 5. And then you still have a subtract 2. So what is this, a positive number or a negative number? Negative. It is. And 5 times 5 times 5 is? Right. And then you're going to subtract 2. So you're, what'd you get, Zig?
Negative 1.7.
Negative 127. Good. Vanessa? Sure? Okay. Noah?
How do we tell that that isn't 10 minus 15 times negative 2?
No, it's subtract. Good question. Okay, so you could actually come ask me. That would be something to come ask me on a test. But if I wanted this to be a multiply by negative 2, in that case I would have put a dot. And then the little negative higher, or put parentheses. So 2 ways to write it to answer your question. I could have changed the problem. So if we did a new problem, and it was supposed to be multiply, I would probably just do this right next to each other. Because parentheses next to parentheses means multiply. Okay, but that's a different problem. Olivia?
For number 6, wouldn't negative 5 times negative 5 times negative 5 be a positive number?
No, because negative 5 times negative 5, right here, that's 25, positive. And when you multiply 25 times a negative 5, you're back to a negative. You see that? Cameron?
Yeah.
Oh, yeah, well, we're just gonna roll with that. Number 6 is, so this is the second number 6 right here. So second number 6 is saying, what's the opposite of m squared? So you're gonna have that negative sign, and if you look up here, there's your m value. So you're gonna put your m, this is one way to do it, like that. And so then you have to calculate the opposite of -4 squared, which is just 16. Another way to do that, I think for some people it might be easier, is to go up to the beginning of the problem, and right when you see m is -4, write down what m squared is. When you square a negative number, you're going to get a positive. And then you could just take the problem and say the opposite of m squared. Well, you know m squared is 16, so the opposite of 16 is -16. Yes?
What would you do if there's, like, why are there, like, 2 negatives next to each other?
Right here? Because this negative right here is the opposite, and the m squared, this right here, you have to figure out what m is and put it in there, and then you have to square it. So m is -4, so you have to write it like that. Does that help? So over here, in other words, we'll just keep, here's another example on 7. Now you have the opposite of m. m is -4, so I would write it like that, which is 4, right? Squared, which is 16. Natalie, did you have a question? That's just what you're going to say? Keep going. Okay on that? So do you see the difference of these two, Skylar?
Yeah.
Okay. So let's go down a little farther. Remember, let's rewrite what these values are. M is -4 and P is 2. So I don't have to keep scrolling back and forth. So I'm going to take NP, remember this is a multiply, so I'm going to do -4. You can put a dot if that helps you, times 2, subtract 5, times -4, times 2, you're right. Thank you. So now I'm going to do the multiply, so this is -8, take away 10. So think of this as like temperature. If you're 8 degrees below 0 and you drop 10 more degrees, yeah, you're still negative, -18. How are we doing? Okay. So over here, 2 times p squared. So that would be 2 with an exponent. I'm just going to copy the problem and put the substitutions in. So the m, I put in a -4, then take away 1. Now I'm going to go through orders of operations, so I will do parentheses first. So that gives me -5. Copy the rest of the problem down. So then I get 2 times 4, take away, what's -5 squared? Z. It's positive 25. Right. That's right. So this is 8, take away 25. And that's negative. So you're starting at 8, and you're taking 25 away. So think of this as a number line. If you're at 0, you go over to 8. That would bring you here, but subtraction sends you back the other way. So if you subtract 25, this is 25 units long, you're going to be in the negative down here. What's that number going to be? Negative 17. That's right. Does that make sense? Okay. Let's go to the next page. I did forget. This is what I'll do, you guys. I will. I'm gonna break this up a bit so I can fit 10 in. We'll get 10 in. So remember, if you have m squared, you could do m squared first. And m is -4, so m squared is positive, right? So you get 16 take away, and then you have m, so that's -4 times p, which is 2, all over the opposite of m squared. And we know m squared is 16, so you're going to have it over -16. That's a hard problem. Does that make sense? So this becomes 16 take away a negative. So you could write this as positive. So 16 plus 8 all over -16. That's right, 24 over -16. So reduce that fraction, and you get positive? Not positive. It's -1.5. Okay. So let's go to the next page. What I'll do is I'll go through as many of these as I can, but I'll actually just finish the recording and then I'll post it. I have a substitute tomorrow and I'll have them play the second half. And then you guys can check your work. How does that sound? Okay? So we won't get through everything, but you don't need to worry about that. Okay, so finding the product. The directions tell you to use the distributive property. So the distributive property is that little rule that tells you to take the number here and multiply by the number there and by the number there. So when there's a variable in the beginning, there's going to be a variable in the end. So 2 times x we write as 2x. And then you bring the subtraction sign down. 2 times 4 is 8. And that's actually the whole problem. You forgot to do the second part. So practice again here with the negative. -3 times x we write as -3x. When I multiply a negative times a negative, so when you look at this part here, this is like a negative times a negative. So it becomes a plus, and then you do 3 times 4, which is what, Natalie? 12. Question? You're going to need to get into the habit of putting the constant, the number part, before the variable part. So this is the last thing I'm going to do today. I want to make sure that you understand what it means to use the distributive property on a problem like this. Find the cost of 7 t-shirts if one costs $9.96. Any ideas, Emilio?
So I just did $9.96 equals about $10.
Okay.
And then I did 10 times 7, which is $70. And then I did the 4 cents that
Good.
we didn't use times 7.
So one method, Emilio's method, would be, think of this, right? Think of this really as close to $10, right? So he did 7 times 10, that's 70. But he knows he's a little over, so it's chunking. So he said 96 cents is 4 cents off of what he estimated. So he's going to subtract 7 sets of 4 cents. So he's going to subtract how much money?
38 cents.
Yeah, it's under 28 cents. And so he's using the distributive property because he's breaking it into parts. That's the distributive property. So what would your final answer be? It must be 69 something, right?
Yes,
69, 72, don't forget your units, $sign. And that's your answer right here. That's one method that works really nice. Anybody do it differently? Skylar? Okay, so if that were a test question, I would only be able to give you part credit. She said she just did 9.96 times 7. You get credit for the right answer. But if I'm asking you to use the distributive property, I'm expecting you to break it up. So another way to break it up, can anybody think of another way to break it up? Noah?
Well, I broke it up the same way as him, but then I did like the math, and like 99.96 times 7, and I got 74.6.
So you broke it up, like,
And then I tried to check my answer.
but you know it has to be less than 70, because this is less than 10, right? So you made some careless mistake. Okay, so the other method, you could do, I think his way's the easiest, actually. You could do 9 times 7 and add it to 90 times 7. But it's a lot more work, and then you'd have to add it to 6 times 7. You know? More work. His work is cleaner, but this also is an example of distributive property because 7 is in all 3 parts. So this would be $63. This would be what's 9 times 7? $6.30. $6.30. And this would be how much money? 6 pennies 7 times. 42 cents. So here you get 69.30, that's correct. Plus 42 cents. And you end up getting the exact same answer, $69.72. So the goal is that you could demonstrate your understanding of distributive property with either method. Okay, so we'll continue with problem 14. Problem 14 is asking you to write an algebraic expression. So you're going to have a variable in your problem. And that variable, you can use the letter N for number, or you could use X if you prefer that. So you're doing 7 times a number. That's 7 times a number like that. You could put 7 dot N if that makes it a little bit easier for them to understand. And the word decrease means to subtract. So you're going to take your 7 in and you're subtracting from that 6. That's how you write an algebraic expression. So an algebraic expression has a variable in it, the variable's n, and it has a math operation. We have multiply here and we have subtract. Okay, let's go to this last problem. Take a little bit of time to read the last problem. So a deli has 52 kinds of cold cuts. So when you read a word problem, you might want to highlight important things. 52 types of cold cuts. There are 18 fewer kinds of cheese than meats. How many? So the question that we want to answer is to find out how many kinds of each type of food. So each type, how many kinds of cheese and how many kinds of meat there are. So a deli has 52 kinds of cold cuts. So what we know is out of all of those cold cuts, there's meat and cheese. And we want to figure out how many kinds of meat and how many kinds of cheese there are if there's 18 fewer kinds of cheese than meats. So in your class, really the best way to do this is keep it simple and use a table like we've been practicing in the homework, or you could make a column titled meats and cheese and the total, and we know we want the total to be 52. So then you could start with an educated guess. So maybe you might start with 30. You start with 30 kinds of meat, and you reread the problem. It says there's 18 fewer kinds of cheese. You would have to subtract 18 from 30, which would give you 12. So then you could add these together, and you get a total of 42. So that's too low, which means you need to increase one of your values. So then you have to decide if you want to go up or down. So let's suppose you go up to 35. If you subtract 18 from 35, when you subtract 18 from 35, you get 17. So that would mean that you have 17 types of cheese. Then you would add your 35 and your 17. And when you add 35 and 17, you do a little scratch work here. You end up with 52 types of cold cuts. That worked out quicker than I was expecting, so I had a good guess. And so since I have the total, then I know that there's 35 meats, 35 kinds of meats, and 17 kinds of cheese. Another good problem that you could do with the table would be the ones from chapter 1 that we did, maybe section 2, but also on your quiz we did a problem with adult tickets and student tickets, and a table works really well here too.